All right, here's a problem that's similar to page 616, number 5 in your book. So number 5, page 616. And basically what's happening is a canoeist is going upstream, so they're fighting the current, and then they're going downstream with the current, so it's going to be easier. So again, as soon as you see hours, kilometers per hour, things like that, you know it's distance through time. So make a 2 by 3 grid. And so basically he's going with a current, so with the current, and then against the current. Right, and so it tells you how much time it takes. They pedaled 4 hours with a current, so distance equals rate times time. And obviously it took a lot longer, 10 hours, when they're fighting it. So again, I'm just going to put D and D and R and R here. Now I know this is false because obviously if the time is more than double, the distance couldn't be the same and so forth. So I know this is wrong, but I'm going to fix it. All right, so is the distance the same or the rate? Well, it says basically the return trip. So the distance is the same both times. So I need to fix my rate. And the thing that's impacting the rate is this current right here. Right, so that current is what's going to change my the rate. So if I go with the current, it is going to push me along. So I'm going to add 6 to that. But it is also going to slow me down when I go against it. Right, just like riding a bike with the wind is going to push you faster, but against the wind is going to slow you down. So I get my two equations. Distance equals rate times time. And over here I get distance equals, and again you need parentheses, rate times time. So erase that again, sorry. So times 10. All right, so I need to distribute these. All right, so distance equals, I could distribute that and get 4r plus 24, and distribute that and get distance equals 10r minus 60. Now again, you could, if you wanted to, bring your r's over and do elimination, but I like substitution here. So if you look as far as substitution goes, if these two are equal and these two are equal, then I should be able to sub those in there. All right, so I'm going to go ahead and do that. So I'm going to replace this d with the value that is equal to it. So 10r minus 60 is going to be the same as 4r plus 24. And again, I just took this guy and subbed it in where that d used to be. All right, subtract my 4r's. And I get what? 6r minus 60 equals 24. Add 60 to both sides. And I get what? 6r equals 84 divided by 6. R goes in there, what? 24, that would be what? 14. Right, so I get 14 for R. Now that may or may not be what they're asking for, so let's go back and look. Find the speed of the canoe in still water. Well, that is what R is. It's the rate of the canoe if there was no current. So that would be what? In kilometers per hour, I think, or what did they? Yeah, kilometers per hour. Right, so that should be kilometers per hour. All right, so 14 kilometers per hour is my answer.